DC.
Hello, good evening. How are you all? Hello, am I audible? Hello, am I audible?
Yes, sir. Yes, sir. You are audible. Yeah, good evening, sir.
Good evening.
Okay, so guys, do you have any questions or doubts related to the last session which we had yesterday?
No, sir, I don't have.
Okay, fine. So in last class, we discussed about 7 segment, 14 segment, 16 segment display, and I gave one assignment to try printing M on 14 segment common cathode display and printing N on 16 segment common anode display. So I hope you have completed. If anyone has any questions, let me know. Otherwise, I will start the next topic. Okay, fine. So let's start the new topic. Now we have completed two simulation topics. The one was LED interface and the second one was segment interface. And in last session, we also discussed about one IC that was 4511, which basically converts BCD to 7 segment. So we already know about binary coded decimal to 7 segment displays. Now we are going towards the next topic, which is called motor interfacing, So let's pick motor. So here we have to use this active simple DC motor model. Today we will try to wind it up with all the simulations, and tomorrow we will try to start the programming part. So we have a motor and we have two terminals of this motor. This one is the positive one and this one is the negative one, right? How to identify which one is positive? Generally, whenever you drop the motor, the top one is positive and the bottom one is negative. But suppose if you rotate before dropping the component, you can check the label here. As we have seen the label in 7 segment and 14 segment displays, here it will print the property of your pin. So if I put my cursor on this pin, I can see the name is positive. And if I put my cursor on this pin, I can see the name is negative. That means this one is positive and the bottom one is negative. So what if we have to rotate this motor in clockwise direction? We have to give the positive of battery to the positive of motor and negative of battery to the negative of motor. Now we have two ways to pick power. The one was battery and other one was power from terminals mode. I told you yesterday how to pick power from terminals mode. Simply you have to click right on your screen, place, terminal and power, and otherwise on the left hand side we have the terminals mode. So we can select the power from here and accordingly we can select the ground from here. So now let's connect the ground to this and the power to this one. Now if I play, we can see the motor is rotating in clockwise direction. The motor is rotating in clockwise direction. Now, if we have to rotate this motor in anti-clockwise direction, we need to simply switch the polarity. That means the power must be connected with the negative of motor and the ground must be connected with the positive of motor. So let's do the same thing. I'm connecting ground here. And if I click play button again, we can see the motor is now rotating in anti-clockwise or counterclockwise direction. But if I show you one more thing, see, generally when we work with robotics, then we have mostly 12 volt of DC motor. I'm using a word mostly, okay? Not all the motors are 12 volt of DC, but generally when we work with small robots, we use 12 volt of DC motors. And currently, if we see, this is the source which has by default 5-volt supply. That means if I connect a battery source here, now I'll be connecting one battery source here because the operating voltage of this DC motor is 12 volt of DC. So I'm connecting this battery source which has 12 volt energy and connecting this positive to positive and negative to negative. We know the direction of motor will be clockwise, but you have to feel the difference in the speed of both the motors. Let me do one more thing. I'll make it clockwise only so that we can compare it easily. Play. So now we can see the left motor is a bit slow as compared to the right motor. And why? Because the left one is getting only 5 volt of DC, whereas the right one is getting 12 volt of DC. And as I told you, the operating voltage of this DC motor is 12 volt of DC. So in this case, when we are giving the 5 volt, we can see the motor is bit slow. And this is simulation. The fact is when we use this same power source with DC motor of 12 volt with hardware, it may happen that motor is not even rotating. Or suppose if the motor is having its maximum RPM of 100, that means 100 revolution per minute, might be possible it's working on 10 RPM or might be possible it's working on 20 RPM. So that completely depends upon the size and the load of your robot. Suppose you are creating a small robot which has a load around 100 grams, then possibly this 5 volt DC motor will work. Yeah, this is obvious. It will not give you 100% efficiency. But if the load is around 1 kg, definitely this motor is not going to work at all. So what I mean to say by all these things, whenever we use DC motors of 12 volt, we need to give it the power source of 12 volt of DC. Correct? Now we know about the fact how to make it clockwise and how to make it anti-clockwise. So this was using the direct power source. Now, if you remember yesterday, I told you one thing, and that was logic toggle. So now I'm picking logic toggle. Why? So that we can compare the speed of motor if I give the logics from controller. I also told you one thing. Consider these logic toggles as a replacement of your microcontroller till the time you study about controllers. I have not told you about the programming. We have not started any controller yet. So we have to consider these logic toggles as the output pins of microcontroller. Now I'm connecting this logic toggle considering that we are getting the logics from microcontroller, and then let's click play. Now if I give the logic 1 from the first terminal, again the same thing is happening. The motor speed is bit slow as compared to the right one where it's getting 12 volt of DC. We already know that these logic toggles provide only 5 volt of source, and in the same way microcontrollers also provide the 5 volt of source. So definitely we cannot connect our motors with the microcontrollers. This will be very difficult for us to get 100% efficient output of the motor if we connect it with microcontroller. So this is challenging part for us because we want 100% efficiency. Also, we have to connect it with microcontroller only because we have to program it. We want to make it automatic. If we connect the motor directly with the power source, that means we have a control whenever we want. We can make it clockwise whenever we want. We can make it anti-clockwise just by changing the polarity. But it's not going to work in the hardware. Suppose you are creating a robot and you asking a robot to go 10 meters and pick an item from me. Let's say you are playing football and you are alone and your robot is there with you. So you just kicked to the goal post and the football goes somewhere else. Now you asking the robot to go there and come back with football. But your robot is capable to go because you have connected the wire with battery in a way it may go clockwise direction or it may go forward. So it's going, picking up the ball But when we asking it to come back, it's not possible for it, because that time we need to change the polarity. So that time you need to go to the robot, you have to change the wiring, and then your robot will be capable to come back to your place. So this is like what we are doing. If we have to go, if we have to change the polarity, then what's the need of robot? We can pick that ball by ourselves. So what I mean to say, if we do not use microcontroller, it will be very difficult for us to change the polarity. Also, sometime it may also happen that we are asking the robot to just work for 10 seconds or just work for 5 seconds. Or sometime it may happen we want it to go sleep for 10 hours and then restart your work. So that all things, whatever we are just discussing, we can do that by using programming. And programming mean we need a microcontroller. We need a programmable controller. So on the left hand side, currently we have given the logics from microcontrollers. At positive pin it is 1 and negative pin it is 0, but unfortunately it is just 5 volt and the motor is not working with 100% efficiency. And I'm not asking 100%, at least it must work with 90% efficiency, but it's not working. So here we need to use an IC which is called L293D, which is called L293D, correct? So let's connect one IC here. L293D is called motor driver IC. So I'm going to pick L293D. This L293D is 16-bit 16 pin IC. It has total 16 pins, 8 on left side and 8 on right side. Whenever we see any IC, we see a half moon shape on this side where I'm putting my cursor. Actually, it's simulation diagram. So here you can't see that half moon shape. Also, if we start counting the pins according to that half moon shape, just left to that, top to bottom, there are pin number 1 to 8, and on the right side, bottom to top, the pins are 9 to 16. As I said, we have 16 pin IC, 16 pin, right? On the left side, pin number 1 to 8, top to bottom. On the right side, bottom to top, it's 9 to 16. I'll show you the actual diagram of this IC. Just wait. I'll show you here. L293D pin diagram. So here we can see this is half moon shape, top 1, bottom 8, right side, bottom 9 and top 16. So this is the actual pin diagram. When we purchase any IC, we have to connect in this way. But right now we are doing simulation, so let's try to understand according to simulation. Now on the left side, we have pin input 1 and input 2. Whatever logic you give to input 1, it gives the output to the pin output 1. That means output 1 and output 2 gives you the logic corresponding to the input from input 1 and input 2. In the same way, output 3 and output 4 can give the output logic corresponding to the logics from input 3 and input 4. Now, what was the reason connecting this L293D IC? Because I told you this is called L293D motor driver IC. We can drive the motors easily using this IC. But as I said, what I just told you, that this output 1 will get the logic from input 1. So for example, if I connect this logic to input 1 and if I connect this to input 2, and if we give logic 1 and 0 from logic 1 and 0 to input 1 and input 2 respectively, it will give the logic 1 and logic 0 to output 1 and output 2 respectively. But the difference is, you know what? Here we give 5 volt and here we will get 12 volt. If I connect this output 1 with positive of motor and output 2 with negative of motor, here we are giving 5 volt and here we will get 12 volt. Correct? That does not mean that this IC is boosting your energy. It's not converting 5 volt DC to 12 volt DC. No, actually, we need to convert an external power source of 12 volt of DC here. How to make it 12 volt? Right now it's 5 volt of DC. So if you want to make it 12 volts, simply double click on this, double tap on this and type 12 volt. It's asking for a string. So type plus 12 volt here. So now if you give the logic 1 to input 1, which is 5 volt, output 1 will provide 12 volt. If you give the logic 0 to input 1, the output 1 will also provide the 0, that means 0 volt. So actually this external voltage is passed to output 1, output 2, output 3, output 4 only when input 1, 2, 3 and 4 are giving logic 1. So now it is very simple. We have given 12 volt of DC external to pin number 8, and then I am connecting another power source to pin number 16, which is called VSS logic supply voltage to energize your IC. Then input 1, input 2, output 1, output 2. All these pins are on the left side of the IC. As I told you, this is not the actual pin diagram. But if we see the actual pin diagram, you can see all the pins are here. Input 1, in output 1, in output 2, input 2. That means all the pins related to motor 1 is all the pins of motor 1 are on the left side and all the pins of motor 2 are on the left side. How motor 2? We can connect one other motor on output 3 and output 4, right? So in total, we can connect two motors with this L293D IC. All the pins of motor 1 are on the left side, as you can see here, and all the pins of motor 2, like input 4, in output 3, input 3, these are on the right side. So this enable 1 must be connected with 5 volt if you use the left motors. If you use the left pins mean input 1 to output 1 to. To enable the left side of your IC, enable 1 must be connected with 5 volt. In the same way, to enable the right side of your IC, to enable all the pins of right side of your IC, you have to connect EN2 with the 5 volt source. So currently it is actually not required because we are not connecting the second motor. But in case if you are connecting the second motor as well, then you need to give the 5 volt source to this enable 2. That is it. Now ground. For left side, let's connect only one ground. So we are done with the simulation circuit of the motor driver. Now let's click play and we can see we are giving the logic 1 and 0 and the direction of motor is clockwise. And if we give the logic 0, 1, now the motor direction is anti-clockwise. If we give the logic 0, 0, there is no potential difference. That is why the motor is not working. And even if we give 1, 1 logic, again there is no potential difference and the motor is again not working. There are a lot of people who think if we give logic 1 to both the pins, that means 12 volt of supply to both the pins of motor, motor will get burned. But actually it's not like that because it works according to potential difference. If you give 12 volt on this pin, if you give 12 volt on this pin, that means 12 minus 12 equals to 0. Motor is not going to get any energy, any logic. Now let's connect the second motor. So for second motor, I'm going to pick another motor, connecting it with output 3, which is positive, and output 4, which I'm connecting with negative. If we use both the motors, that means enable 2 must be connected with 5 volt to enable the right side pins. And input 3, input 4, I'm connecting to another logics. And now let's click play. So we can see both the motors are working in clockwise direction. Second motor is now not working. 0, 1, second motor is working in anti-clockwise direction. 0, 1 for first as well. So both are now working in anti-clockwise direction. So as I told you, these are the logics from microcontroller. So later, whenever we need to rotate one motor clockwise, another motor anti-clockwise, or both anti-clockwise, or both clockwise, or both stop, we can simply change the program every time. We have to write that in programming, which time, what exactly we have to do, and it will perform all the duties automatically. So I'm done with this topic. If you have any questions, any doubts related to this motor driver, just tell me. Otherwise, I will move to the next topic. Are you guys there?
Yes, sir, no doubt.
Okay, that's good. I can see like the strength is low today because I shared all the videos. That is why I said in last session also, I will not upload all the videos on the same day because I know about the students, they start missing the classes if they are getting the recordings.
Yes, sir.
If you want recordings only, then there is no need of these live sessions because my sessions are pre-recorded. I recorded those sessions in 2015 only. So it's been 9 years. Everything is recorded. If you want recorded, no need to come to live class. Just tell the counseling team that we want to move ourselves from live mode to the recorded mode, the self-placed mode, and they will activate your account. You can enjoy there. Anyways, let's start the next one. Now suppose I have a lamp. I have a lamp. Now, this lamp is somehow or somewhere related to the LED bulbs or the tube lights which we generally use at our homes. So, what I can say that these lamps or bulbs or LED bulbs or tubes operates at 220 volt of AC. So, I'm changing it to 220 volt amplitude, 220 volt. Now, if I want this lamp to work, we need to connect alternator. Alternator is basically called AC voltage source. So let's pick alternator and drop here. Now, if we see this alternator, here we have the option of amplitude, which we are mentioning 220. Let's click OK. Why I change the amplitude of this alternator? Because right now we have the load of 220 volt of AC. Now let's connect both. We not need to worry about positive and negative in this case as it is AC alternate current. So it is going to change its cycle from positive to negative and negative to positive frequently. So let's click play and we can see the lamp is animating. The lamp is working absolutely fine. Now, when we use these things at a house, we have a button to control. Like whenever we want to turn on the lights or whenever we want to turn off the lights, we have a manual button there. We can keep it on, keep it off. So let's do the same thing. Let's create the same circuit simulation. So now I'm going to pick button. So I'm dropping the button here. Now if I click play, we can see this button is not on. That means it's open circuit. That means the current which is flowing through the alternator AC voltage source is not going towards the lamp and lamp is not working. But if we tap this button to on, it is called closed loop and the current has a path to flow and we can easily see that this lamp is working fine. Now, what is the problem here actually? We are doing automation here, not the manual things, because manual we already have. Even though automation also we already have, but we want to implement those things so that we can create few new projects. Now, if we see here, we have to make it automatic. That means we need the logics from microcontroller. And if we need the logics from microcontroller, obviously we need to connect the logic toggle here. So let's pick logic toggle. But now it is very difficult because this logic toggle is the replacement of microcontroller for the time being, and it provides 5 volt of DC. Whereas if we have to turn on this lamp, if we have to animate this lamp, we need the voltage source of 220 volt of AC. Although we have a voltage source of 220 volt of AC, which is alternator, but the point is how to connect, how to mix everything with this logic from microcontroller. Now this is going to be difficult for us. Let's say if I delete this button, and in the place of this button I am connecting two different logic toggles, the one here and the one here. One I'll keep 1, other one I'll keep 0, so that it can work easily. But we are now mixing the DC and AC, because these logic toggles are giving 5 volt of DC, which we directly connecting to the alternator. So this is dangerous. We cannot do this. That means it's very clear we cannot connect the microcontroller directly to the AC voltage source, because microcontrollers operates at 5 volt of DC. So what to do here? Do you
Sir, I
see that?
think we need to connect relay here.
Yeah, exactly. We need to connect relay here. Correct. So let's keep this side and pick relay. RELAY. If you see, here we have a relay. Now let's forget about this for a few minutes and let's discuss about the relay only. Relay is called electromagnetic switch, which has a magnetic coil, and if we start giving the supply, the DC logic to the input side of the relay, it generates the electromagnetic field. And if it generates the electromagnetic field, it has the property of magnet. That means if there is any magnetic material around this, it will attract to that. Now, what I mean to say, here we have electromagnetic coil. If we give the supply to these coils, so I'm keeping it logic toggle, and other side I'm keeping it 0. That means if I do 0 0, there is no potential difference, relay is not going to work. If I keep it 1 0, there is a potential difference, and it will start generating the electromagnetic field. Now the best part is there is no physical connection between the input and the output of the relay. Physical connection means whatever logic, whatever current you are giving to the input side of relay, you are not going to get that to the output side, because output side is separated to the from the input side, right? There is no physical connection. So what is actually happening here? If you give the logic 1 and logic 0 to this relay, it will generate the electromagnetic field. As a result, we will get magnetic properties, and the switch, which you can see here in the gray color, will attract towards magnet. So it will come to this point from this point. What I said, it will come to this point from this point if you give the logic 1. Otherwise, it will remain to its initial point, which you can see right now. Let's see, is it happening? No, because we are giving the logic of 5 volt, and right now the operating voltage of relay is 12 volts. So I'm making it 5 volt only. I'm making it 5 volt only. Now let's see. Yeah, now it's triggering. As soon as I give the logic 1, it has magnetic properties, and the switch is attracting towards the magnet, and it's leaving its position of closed. Here it was closed, coming to the open point. This is called normally open point, which is open in normal position. Normal position means when we give the logic 0. And this is called normally closed point, NC point, which is closed when we give the logic 0. That means it is closed in normal position. So if we give the logic 1, the button is coming to this side. That means these 2 points will help us to create the path for this alternator and lamp. This is called NO point, this is called NC point, and this one is called common point. So let's connect common point with the alternator and the NO point with the lamp. And now we see when we're giving the logic 0, the bulb is not animating. And if we give the logic 1, the bulb is animating, because we can see the closed loop here. In some cases, it may require that when the logic is 1, the bulb must be off. Right now it's doing what? When the logic is 1, the bulb is on. When the logic is 0, the bulb is off. Sometimes if you need opposite, you can connect this wire to this point, normally closed point. Because when you give the logic 0, it won't trigger, and if it's not triggering, the closed loop is there, lamp is animating. And if you give the logic 1, it come to this point, and now the loop is open and path is not completed, so the bulb is not animating. I hope this is clear. Do you have any questions or doubts?
No, sir.
Cool. So now what we did in this circuit, we just changed this 5 volt to 12 volt. Sorry, 12 volt to 5 volt. Earlier when we picked it, it was 12 volt of DC operating voltage relay. Now, according to the requirement, we changed it to 5 volt. But suppose you are making a project, you are in industry, and in spare parts, the 5 volt relay is not available. And you have to complete the project by the deadline of today by using 12 volt only. What I said, we don't have the spare 5 volt relay, we have only 12 volt relay, but using the same, we have to complete the project. Now what we can do? Can anyone give me idea? Quickly.
Sir, I think we need to connect
Sir,
booster.
it can be used.
Booster. Which kind of booster we can use here?
Sir, 5 volt to 12 volt converter.
Buck converter. 5 volt to 12 volt. Okay. Anything else?
Yes.
Okay. Let's do it. Why not to use this L29CD IC? We just completed this. We just need to give the external source of 12 volt of DC to this pin. We did the same with 12 volt motor, right? We were having the logic of 5 volt and we operated the 12 volt motor. Now the same thing is there. We have the logic of 5 volt and we have to operate the relay of 12 volt. So let's use L29CD IC. So now I'm giving the power, the same connections I'm doing, not explaining again what we did that time. So I'm connecting the power to this and
But
enable
sir,
one.
in this circuit, we need external 12 volt.
Yeah, obviously we need. There is no problem that we need in the case of motors also. No worries. I'll tell you how to make external 12
But
volt of
sir,
DC.
in buck converter, we don't need any external 12 volt.
See, what I said, this 12 volt, I'm using a word external, but actually when we use the controller, that time we get 12 volt also. We get 5 volt also. Okay. In the controller only, we have the pins to get 12 volt as well. I'll tell you how. Don't worry. Tomorrow or whenever we will have next class, that time I'll show you how to create the power supply circuit for 12 volt and 5 volt, which we provide to microcontrollers. So now let's connect this here and let's connect ground here. Why I'm connecting this to ground? Because this pin needs 1, which we can get from here, from input 1, and this pin always needs 0. So let's connect it directly to the ground. If we can also connect it with output 2, but in that case, we need to give another logic toggle to input 2. If we give another logic toggle, that means we are using one extra pin of our microcontroller. So now if I click play, I tap here, I can see the relay is triggering. Correct? Now it is connected to the NC point. That is why when logic is 0, then the lamp is animating. And when the logic is 1, the lamp is not animating. So let's connect it to the NO point. So if I give logic 0, the lamp is not animating. If I give the logic 1, the lamp is animating. Tell me, is it clear or any doubts? No doubts? Okay, good. So see, I guess Ashutosh was saying we can use the buck converter Yeah, we can use. There is no problem. We have 5 volt to 12 volt, 5 volt to 24 volt buck converters. And currently, if I tell you, when I started my career, that time the buck converters were not so successful. But now it's been 12 years, and I am seeing that there are a lot of buck converters which have a good, very good efficiency. So we can use 5 volt to 12 volt buck converters as well. But it will increase the cost of your circuit. If it will increase the cost of your product. When we ask for any buck converter, it will cost you around 200 rupees. But when we ask for this L293D IC, it comes in just 10 rupees. So we don't have to increase the budget as well. We have to minimize the budget while working with any project.
Sir, else we can use voltage regulators.
Voltage regulator actually drop down the voltage. It does not increase the voltage.
Sir, used for like we if we want 5 volts, then we use 12 volts to 5 volts converters
Exactly.
using ICs.
Yes, exactly. This was the only idea of mine, which when I said I'll creating power supply in next class. So in microcontrollers we have to give the 5 volt, right? And we don't have any source of 5 volt of DC. We have a source of 220 volt of AC. So we will be converting that 220 volt of AC into 5 volt of DC. So we will be creating that circuit in a way. Let's convert 220 volt of AC to first 12 volt of DC and then 12 volt to 5 volt of DC. So we can give that 12 volt here and we can give that 5 volt here and the microcontroller as well. So this was the idea of creating that power supply circuit. Actually, we need power supply, so we just need to include one more component there, that is voltage regulator 7805. Got it?
Yes, sir.
Okay, fine. So that's it for the day. If you have any questions or any doubts, still we have 2 minutes to complete. And tomorrow, I'm not sure I'm available for the class or not, because tomorrow I'll be traveling. If I reach on time, I'll take class. I have to go my hometown. So after my office 7 o'clock, I'll start traveling. Around it's 2 hours, but sometime it may get longer because of traffic. I'm not
कोई
sure
नहीं
about
सर,
it.
एक आध दिन की मिस भी कर देना.
देखेंगे, no problem. So if I'll be on time, I'll inform you. Otherwise, we will keep that class on Saturday.
ओके सर.
Okay. So if you don't have any doubts, let's end it. Good night. Bye bye. Take care. Keep practicing.
गुड नाइट सर.
Okay, good night.
जय बाबा की सर.
Jai Baba Gi.